Hi, everyone. Say hi, Mrs. Bear.
Hello.
This is our lunch in quotes review, and Mrs. Bear and I are going to talk about problems that will be similar to the problems on your math test tomorrow. Okay.
All right, so this first problem, I want to solve for x, and you'll notice that this problem has fractions in it. It would be much easier to solve if I didn't have fractions, so I'm going to use fraction busters. I'm going to multiply the whole equation by the least common denominator, which in this case would be 6. If I multiply this fraction by 6, the 6's cancel, and that just leaves me x plus 5. If I multiply this fraction by 6, this 2 goes into that 6 3 times, but I have to multiply that 3 by the quantity 2x minus 1. And then I'm going to go ahead and distribute here. And that'll give me 6x minus 6. Should write clearly for you guys. I'm going to move the x's to the right side. I think that would be nicer. So I get 5 equals 5x minus 6. I'm going to move my constant to the left side by adding 6 on both sides. I get 11 equals 5x. Divide both sides by 5. And since 5 doesn't go into 11 evenly, I'm just going to leave it as an improper fraction. And there's my answer. Some of you, when we talked in class, in Mrs. Bear's class today, talked about how you could also solve this with cross products because it's a proportion. And that would still work the same way. You'd still get the same answer. It'll look a little bit different because of the common denominator, but you'll get down to the same answer. So that is another method you could use. Miss Reynolds is going to do the next problem for us.
Okay.
We're going to be switching, so
Hi, everyone.
sorry. Hello, Miss
So
Reynolds.
this is an exponential problem similar to the one you'll see tomorrow. My purpose is to get this to be simpler by getting those bases to match each other. And I can see right away it's going to need to be a base of 6 because I can turn 36 into 6 squared. So 6 times 6 is 36. So for my second line, I'm going to write 6 to the 18 minus x is equal to 6 squared to the 4x. Because of properties of exponents, I'm going to multiply a power taken to a power. So this was basically 6 to the 8x and 6 to the 18 minus x. So now that my bases are the same, I can drop the bases. I can drop the base.
Boom, boom.
Boom. And then I get 18 minus x equals 8x. And I think I'll move my 8 over here by adding x to both sides. There's a 0 pair. 18 equals 9x. I'm going to divide this whole thing by 9, and I get 2 is equal to x.
Excellent. Now we're going to move to the other side of the room. If we make you dizzy, just close your eyes for a second. Miss Reynolds, you want to do your graph problem?
Okay, so you'll be asked to find the context for some statistical displays like this scatter plot. And here I'm comparing absences, as in school absences, to test scores. And the instructions say interpret the data in context or something similar. So I noticed that as absences increases, my test scores are decreasing. This is a negative correlation. So when I answer this question, I'll use these two variables, and then I'll say because this is a negative correlation. So the answer to this, it's a different color, will be as absences increase, test scores decrease. Scores decrease. And then you can add another line saying this is a negative linear correlation. Right, Mrs. Bear? That'd
Yeah.
be about right?
Mm-hmm.
I'm not writing a complete sentence, however, you will write a complete sentence. Negative linear. Oh, correlation, C-O-R-R.
Yeah.
Hope that's how you spell it.
Yes.
Okay,
My
so
turn
I
again.
think Mrs. Bear is next. Okay.
All right, so this is working with linear equations. I want to write the equation of a line that's perpendicular to this equation here, but passes through the point 10, -2. So first I need to think about what is the slope of my line going to be that's perpendicular to this one. And you might recall that when lines are perpendicular, their slopes, if I multiply them together, will have a product of -1. So for that to happen, this slope is going to have to be the reciprocal, but it's also going to have the opposite sign. So this is what I'm looking for. And you guys remember we called it the opposite reciprocal. So my slope is -2/5, and my point is 10, -2 from there. And so now I'm going to plug into y equals mx plus b and find out my value of b. So y is -2, m is -2/5, x is 10, b is what I'm trying to find. I can cross cancel here. That would give me -4 plus b is equal to -2. And to isolate b, I'm going to add 4 to each side. And I find that my value of b, my y-intercept, is 2. My y-intercept is 2. And I know my slope is -2/5, so I get y equals -2/5 x plus 2. And that would be perpendicular to this equation because their slopes are opposite reciprocals, and it would go through the point 10, -2. Ms. Reynolds, your turn again.
Okay.
We're moving to sequences now.
Yeah. So here is a sequence I have. I've listed just the sequence numbers 20, 17.5, 15, 12.5.
Decimals.
And they're decimals. I'm asking for the type first. So in order to figure out the type, I'm going to see what's happening each time. I can see right away that it looks like I'm just subtracting 2.5. And it happens throughout the sequence, so I know this is indeed an arithmetic sequence. My handwriting's getting sloppier as the video goes on. So then the question is, give me an explicit equation and a recursive equation. So the explicit equation is similar to y equals mx plus b.
When it's arithmetic.
When it's arithmetic, because this is a linear increase as well, or decrease in this case, as well as this is linear. So I'm putting it in a different format though. I'm saying t of n is equal to m, this is my multiplier, times the number plus the y-intercept. So these will be the, this will be the format I use. I know that my decrease each time is -2.5, and that's the same as my slope. But I don't know yet my b value, so I have to go back and think about what the zeroth term would be. So if I'm giving you a sequence, I'm always giving you sequences with term number 1, and then term number 2, and then term number 3. But I don't have term number 0 listed. So I have to add 2.5 to get to that, which would be 22.5. And that will be my b value. So when I write this, it will be t of n is equal to -2.5 times n, I'm sorry, n here, and then plus 22.5.
Yes.
Okay, right? And then recursive is, the form is t of n plus 1 is equal to t of n, and then we're going to add our common difference. Today in class we did an increasing sequence, but this is a decreasing sequence, so I'm subtracting 2.5 each time. So this will be a negative number here. So all I have to do for this is subtract 2.5. But this could be any term of sequences that has a difference of 2.5. I want to anchor it to this term by making by naming at least one of the term numbers. I might as well name term 1 is equal to 20. So this combination of these two sequences, these two equations, is going to be the recursive thing.
Equation.
Equation.
Okay, one more.
Okay, one more.
One last one. All right, so we have another sequence here, and this time if you notice 180 is getting small pretty quick, and if I subtract and then subtract again, it's clearly not going to be a common difference. So it looks like maybe it's going to be getting divided by something or multiplied by a fraction of some sort. So I'm thinking if I divide by 3, I would get 60. That's the same thing as multiplying by 1/3. So then if I divide by 3 again, or multiply by 1/3 again, then I'm going to get 20. And 20 times 1/3 would be 20/3, and I could keep going. It gets a little harder with the fractions, but you guys are capable of it. So this would be a geometric sequence because we have a multiplier. My explicit equation. I'm going to start, like Miss Reynolds did, with T of n. And we talked about how arithmetic sequences over there, they fit a linear model, but geometric sequences do not fit a linear model. They fit an exponential model. So I need my 0th term. So the opposite of multiplying by 1/3 or dividing by 3, if I go this way, I'd be multiplying by 3. So I need to do 180 times 3. So I would get 540 as my 0th term. And so I'm going to take my 0th term and I'm going to multiply it by my multiplier, which is 1/3. And I'm multiplying by 1/3 again and again and again and again. So I'm doing that n amount of times. So if I'm on the 5th sequence, I have to keep multiplying by 1/3 over and over again to get to that 5th number in the sequence. My recursive, I want to know what the next number is, and I base it on what the previous number was. So this represents some previous number in my sequence. I don't know which one, it's some number. But I do know that to get from number to number to number, I have to multiply by 1/3. But I have to know something about this sequence first, and like Miss Reynolds mentioned, you normally would tell me what the first term was in the sequence, and that's 180.
Thank you guys for listening.
Good luck.